As I'm recording this from my living room, and as you're watching this, there are a lot of brave people out there fighting the COVID-19 pandemic from the front line. There are also a lot of people working behind the scene to provide all the essential supplies and equipment to these frontline workers. If you're one of those manufacturers working hard to ramp up production, this message is for you. Quite honestly, when I realized the speed and the amplitude of that crisis, my initial reaction was quite selfish. I thought about my family and my team and my company, how we're going to get through this safely. But after a while, I realized that we're all in this together. I realized that this thing is much bigger than all of us. And it really inspired the team at Robotiq and myself to think about how we can contribute to the global effort. And that's how this idea of Cobot versus COVID initiative came up. The idea is pretty straightforward. We want to put all of our best effort, do everything we can to help you deploy cobots within 2 weeks if you're in a situation where you need to increase capacity and want to put some of your workers out of harm's way. So you listen to this idea and you say, it's great, but I wish I looked at this 6 months ago because right now it doesn't make sense. Right now we're in crisis mode and it's not the time to implement a new technology on the factory floor. My goal here is to have you think twice because I think it is worth looking at it at least, if not giving it a shot. What if in 2 weeks from now you had that first robot working? What if in 4 weeks from now you would have 10 of them? You could duplicate that first project and have 10 robots helping your workers, giving them a hand, making and packing your products. What difference would that make for them, for your organization, and for your customers who are on the front line? Following this short video, there is a presentation that explains you how we can do this, what are the criteria to make it successful. So after you watch it, you're going to be able to say whether or not it makes sense for you to explore this. And if you think it is worth exploring this, we'll be ready, the Robotiq Cobot versus COVID Task Force, to give you a hand on this.
All right, let's dive into it. So what is that Cobot versus COVID initiative? Before explaining in detail, I'll just give you a quick background on where we're coming from. So we founded the company to free human hands from repetitive tasks. And robots are great for that. They love doing those boring tasks that humans typically don't like to do. To free human hands, what drives all of our effort is really that mindset of starting production faster. So we try to implement this in everything that we do. So in all of our tools, sensors, software that you see on this screen, there is that idea of starting production faster. So we always have in mind how we can make these building blocks easy to choose, easy to install, easy to program, so our customers can get the robot working and move on to their business, which is building their products. Because in the end, the robots are just a mean to an end. They're just a tool among others on your manufacturing floor. In these crisis time, freeing human hands and starting production faster need to be taken to the next level. And that's really what Cobots versus COVID and this presentation is all about. Also along with this idea of starting production faster, I wrote a book 3 years ago called Lean Robotics. Even if every application is different, I really wanted to standardize the process of deploying cobot cells. So the book contains step-by-step guide, some good project management tools, some tips on how to get started and how to scale. And now again, we really need to push this to the extreme and make an extreme edition of Lean Robotics. And we know by doing this, we can start cobot production within 2 weeks after we decide to move on. So the rest of the presentation will explain how we can do it, and that's what Cobot against COVID initiative is. What we want to do is go from the manual task, design and integrate a robotic cell to have a complete Cobot application that's actually doing something useful on the factory floor. The great thing about cobots is that they're not an all-out, all-or-nothing technology. It is a great 80-20 technology where you can invest 20% of the time and effort to get 80% of the task automated. And that's exactly what we need to do in the current context. There are 3 major phases in the project after you've chosen what you want to automate. The first one is design, the second is integrate, and the third is operate. So the design, it starts from understanding the manual task and having the complete robot cell plan and components ordered. The integrate phase goes from having the part to assembling them, programming, and training your team. And finally, the project merges back into your continuous improvement in the operate phase. So where you turn a key, the robot starts working, and then you fall back into continuous improvement mode. There are many steps in there, but with our integration coach's guidance, we will do them systematically using the guidelines of this presentation. We will also leverage proven remote collaboration tools that we've used in the past to eliminate all communication delays. Before jumping in, let's check 5 criteria that are needed to be successful with the method we're using in Cobots versus COVID. First of all, very important, the application needs to be simple enough for the robot. I'll give a few guidelines on this in a minute, but the first step we would do together is really look at this question and evaluate this together. Second, you need to have an automation team in place with at least 2 members, and this team must be 100% dedicated to this project and committed to move fast. Third, someone in this team must have some prior robotics experience, otherwise it's going to be challenging to do it. Fourth, you need to be able to share information with us using videos, drawings, video calls, etc. If we need to set up an NDA, fine, but it has to be quick. We have to do it and avoid the daily delays that are usually required with NDA. We have to do it pretty much in the first hour of the project. And fifth, ideally, you would need to be able to connect the robot for the startup phase so we can be there with you virtually, accessing the robot to troubleshoot and give you programming advice. So if you check these 5 boxes, we're in business, we're good to go. If not, contact us and we'll make a more detailed evaluation. There are 6 keys to success in making this high-speed project. We'll cover each of them next. And it's good to realize at this point that 90% of what we're going to present next apply to decisions and actions we'll take in the design phase. So even if we're in crisis mode and we want to do everything extremely fast, it's just like the timeless Abraham Lincoln saying, give me 6 hours to chop down a tree and I will spend the first 4 sharpening my axe. That's really the mindset we need to have in this project. The first key to success is to start simple. The source of all successes or failure, it is to start simple. So the first thing we'll do with you is to evaluate the simplicity of the application. And even if a task would have very high impact, if it's not simple enough, we should not do the project in the current context. Because with all the pressure that comes, simplicity will really be our best ally. We absolutely need to find a simple application, get it running, then move to optimize it or move on to the next application. So right now, let's keep the complex tasks to humans who have a high level of adaptability and ease their work by having cobots doing simple tasks on their side. Again, you don't need to automate 100% with the robot, as humans can work alongside. Here's a quick way for an initial rough assessment of complexity for the robot. Because one counterintuitive aspect is that what's easy for a human can be difficult for a robot and vice versa. So to put yourself in the robot's shoes, look at the task you're considering and ask yourself, could I do this with only one hand, even if I was wearing a mitten, and even if I had my eyes shut? So if you could do it, it's a good start. Obviously, we'll go deeper for this with you, but this rough guide can help you do a first filter before contacting us. And when asking these questions, consider the whole task. So not only an ideal case of having the parts on the table. So look at the real task. How are the parts presented? How are they dropped? What is the process in between? Are there any actions that the human is doing without even noticing it, like doing manual tweak to the part or doing visual check, for instance? Here are some typical good cases. So pick and place. So you have islands of automation or you have different stations. You just need to transport parts from one station to the other with a robot arm. Another one is machine tending. So placing parts into a machine, removing parts from that machine, whatever machine it is. Either it's testing machine like on the image or CNC or whatever machine. And packaging, so if the packaging application is simple enough, putting some products in the boxes or putting boxes on pallets. Again, these are a typical example just to give you a guideline, but we'll be with you to evaluate the level of complexity of the task before starting a project. So starting simple is the first thing, and we'll repeat this all the time. It's even more important in those days. And not only you should start simple, but you should stick to simple all along the project. So beware of feature creep. To illustrate this, I use a home improvement project. And we all know this picture is fake because the couple is smiling. and we've all fell into that trap of doing home improvement and doing nice to have along the way. So we might as well do this, we might as well do this, and then the project it drags along, and we blow the budget, and we blow the schedule, and nobody's smiling anymore. So don't do this with your cobot project. Stick to the simplest cell that can bring value. Once it's in operation, then we will optimize. Until it is in production, it creates zero value. And again, the beauty of cobot technology is that it's not an all or nothing automation. We can put it out there, get it to work, and because it's an easy to use technology, we can include it in our continuous improvement efforts after the initial deployment. The third key to success is to standardize on off-the-shelf components. And when you're in a hurry, custom engineering is your enemy because it can create delays at every step of the process. Custom takes time to design. If it's not readily available off the shelf, there is no way it will be in time for starting within 2 weeks. So there's going to be some lead time for the fabrication. Custom parts are not meant to work together and take more time to install. If it's not plug and play, it will take time to program, even basic operations. Custom needs custom training, while standard already has documentation or even e-learning. Custom is difficult to troubleshoot, while standard stuff can leverage an existing knowledge base. And it's the same thing for maintenance. As you can imagine, if you have custom parts that break during crisis time, it can bring the whole cell down for several days or weeks while you get the next custom part being made. So what you want to do when you don't have time is to build an iPhone app. So build an app combining components that are already meant to work together. So like in a smartphone, the camera, the GPS, the processor. Obviously, we're not like this in the robotics world. It's all components that need to be assembled. But if at least they are meant to work together, you will not look like this guy trying to connect good products, but that are not meant to work together. So that's why the idea of plug and play is so powerful in crisis mode. The ability to pick and choose from various modules to build quickly your application. The key number 4 is to start at the start. Sounds obvious, but in the emergency of the moment, and in many projects we've seen in the past, in fact, people are tempted to rush and put stuff together, look at the technology, look at the solution before understanding the problem properly. And you got to refrain from doing that. The last thing that you want is to miss a critical detail at the beginning that you'll find next week when we are implementing on the production line. Take the time to thoroughly understand the manual process. If you can, start with one that you have well documented work instruction. That's the best way to start. Key number 5 is the little brother of key number 4. So once we'll have a cell design, it's going to be important to make a good technical risk assessment. So we're going to list all the things that could go wrong technically, and we're going to rank them with respect to their severity and our level of confidence. And at this point, we're going to invest a little bit of energy and a little bit of time to clear the high severity or low confidence items. So for instance, let's say we have in the concept the idea of using a camera. And let's say if that camera doesn't work, then the whole concept need to be thought again, and we need to totally change the design. So this is an example where the severity would be high because it totally changed the concept. So it's important that we do some small tests to eliminate some of the technical risks that are there. Now, the great thing is that if you use standard building block, if you follow the standardized advice, we at Robotiq or your local partner already have those building blocks, and we'll be able to do those tests very quickly. So just like for number 4, which was to start at the beginning, start at the manual process, if we de-risk early enough and we do it properly, we will avoid a lot of risk of getting stuck in the integrate phase where the stress will be even higher. The key number 6 is something that sums a lot of the previous ones. It's to eliminate all delays. The reality of these robot deployment projects is that sometimes the actual work takes less time than the delays all along the project. So waiting for parts, waiting for answers, waiting for people to come visit us, reworking on things that we didn't do properly on the first time, etc., etc. So the only way that we can deploy a cobot in 2 weeks is by eliminating those delays. And all the previous keys serve this purpose. On top of that, we'll do the project in a way where concurrent actions can happen in parallel. For instance, training you while the material is being transported to your factory. Now, to show you a summary of the process, after showing you all these keys to success, I will pass on the presentation to my colleague Etienne Sanson, Director of Applications, to walk you through the step-by-step process we can do together to help you deploy cobots within 2 weeks.
All right. So let's dive into how we are actually going to deploy your cobot within 2 weeks. Our method will be split into 3 different sections. First, the qualification and preparation of your project. Then the design phase of your project. And finally, the integration and deployment to your production line. The first few steps about qualifying a project, like Sam explained, simplicity is really important in this. Devil is in the details. So once you reach out to us with your project, our staff will do an initial filter, and then they will pass it on to our automation engineers. You will be scheduled for a conference call with them, and we will cover any missing information. Most importantly, at that time, we will set a point in time for a virtual factory tour. This step is really crucial. You will need to walk your factory floor with our integration coach on the line. They will cover all the manual process with you. They will look at the environment surrounding the area where you want to deploy the cobot. The goal of this is to see anything that you might have missed that could later on lead to some delays. So if we miss anything at this point, once we reach your production floor, whatever we find out could cause major delays. So this should be taken seriously, and this will be basically the starting point of everything we do. Once this is done, we will provide you within 48 hours with an answer, so with a go or a no-go, if your project fits what we can do. If it does, we will give you the mapping of the manual process, the mapping of the robotized process, so what the robot is actually going to do. We will give you a preliminary layout of the cobot cell, an initial simulation, and a cost estimate. All that service is exceptionally free in our Cobot Against COVID-19 offer. At this point, you will need to give the go in order to move forward into the design stage. So this next step, the design stage, is really the core of what we will provide you at Robotiq. This will be done by our integration coach staff and our application experts. In this step, you will need to be available to answer some of our questions. So it's really important that you have a single contact point for us, someone who's at the center of this project, someone with a technical background and a broad perspective on the project. Once we go through this, our team will build the cobot cell for you. We will start by doing simulation, so reach analysis, cycle time analysis, so everything that we need to do to meet your criteria. In parallel to this, our designers will cover any mechanical or electrical design that we might have to do. Like Sam said, standardization is key in all this, but to fit the reality of your factory floor, we might need to do some minor customization. That's almost always the case. So for example, we could do custom fingertips to fit a gripper to pick your part. This is perfectly doable within our timelines and should not delay the project. This is the kind of thing we will do. In the early step of the design, we will run through the risking of the project. So we will spot anything that could block the project later on. We will test these in our labs that are actually at home right now. We will do this in order to make sure that we have no surprise when we reach your factory floor. This could lead to a potential stop to the project, but normally everything should go smoothly. In the last steps, we will provide you with a preliminary risk assessment that we will build once the cell is done, the cell design. And we will also build you a custom program template so that later on, when you're on your factory floor with the integration, you will start with these templates we give you. So after all this, closing the design step, we will provide you with a project summary containing everything that I mentioned. So the detailed simulations, the design, the schematics, the preliminary risk assessment, the custom template, your bill of material, and a training plan that fits that. Quoting of the project will be done with your local partner in partnership with us. At the end of this, with all that, if you give the go to this, then you will receive your parts. While waiting for that, you will do your remote training. And when you receive the parts, you will start the last step of the project, the integration. In this step, you will be required to do the job. So basically this last step is the opposite. The design was us doing the job with you in support. Now in the integration, you do the job and we are in support. Following our guidelines, you will prepare the cobot cell off your production line, so offline. You will assemble everything. You will start programming using our custom template. Our integration coach will be there to support you via our remote access solution Insights. This should allow you to go swiftly through the initial programming. Would take within 2 to 3 days to basically build a cell and program it. Then you do a test run offline, make sure that it works according to your spec. And then the crucial point is going on your actual production line, which should be done within a single day, where you will do the final touch-up in your programming, where we will also be in support to you on a hotline, available via the remote access to your robot. So once all this is done, your robot will be up and running. We will go through remote training of your staff, so the operators, according to our custom training plan that we will be doing by conference call with our technical trainers. This would be the last step in order for you to be in production with your cobot. At this point, the cobot should free some human hands that you will be able to use elsewhere in your factory to more valuable tasks. And this would close our project. So if you're interested, that covers everything in our offer. You will need to visit blueprints.robotiq.com to fill out a blueprint. A blueprint is basically our platform for project management. You will start a new project. You give us all the information you have in your on your project. It's basically text that you fill out. If you want to go faster than that, I strongly advise you to just go with your mobile phone and record on the factory floor. Comment while you're recording so that we can actually understand everything that we're looking at. And then when you're ready to send that, upload your video, mention please Cobots vs COVID in your blueprint, and send it. And then we'll get right back to you to qualify that project and get things rolling.